Strangely, it was more difficult to prove that the Earth is rotating than it was to prove that the Earth is revolving around the Sun. Way back in 1610, Galileo, the father of experimental science, provided the first proof that Earth and all the other planets revolve around the Sun. Galileo showed in his telescope that Venus was going through phases like the Moon. The only conclusion possible was that Venus was revolving around the Sun. Case closed. Planets revolve. But it wasn't until 241 years later, March 31, 1851 to be exact, that Leon Foucault proved that Earth was rotating. Foucault installed a giant pendulum from the 220-foot-high ceiling of the Pantheon in Paris. That's a lot of peace. An assembly of scientists and journalists watched as the floor turned beneath the giant pendulum. "The Earth turns," they shouted, mostly in French. Another strange thing about rotation is that although the Earth is rotating at a constant speed, the surface of the Earth is moving at all different speeds at all different latitudes. The same is true for every planet and star. At the equator, the surface of the Earth is moving the fastest at 1,037 miles per hour. That's much faster than the speed of sound, which is a mere 761 miles per hour. Halfway from the equator to the North or South Pole at 45 degrees latitude, the Earth is rotating at 733 miles per hour. Standing at the North or South Pole, it would take you 24 hours just to turn around one time, and that's both boring and cold. One result of these differential rotational speeds of Earth is that it creates belts and bands not only in the atmosphere, but also on the surface of the Earth. Jupiter, of course, is famous for the belts and bands in its clouds caused by the giant planet's rapid rotation of about 28,000 miles per hour. The belts and bands on Earth's surface are somewhat overlooked, but we've got them too. We have white ice at the North and South Poles, and between the two poles, there are alternating belts and bands of dry sandy desert and moist green vegetation. This essential geography can be seen most clearly when we view the Earth rotating in space. Space agencies use the differential rotation of the Earth to their advantage. They launch their rockets as close to the equator as possible. NASA uses Cape Canaveral near the southern tip of Florida. And the ESA, the European Space Agency, uses the Guiana Space Center in French Guiana, South America, almost exactly at the equator. Because the land under a rocket near the equator is rotating at a greater speed, it gives the rocket a boost into space that launch sites near the poles cannot provide. You always want to save fuel, you know. Speaking of Jupiter, as I did about 3 paragraphs ago, the axis of rotation of the big planet is even less inclined than that of the Sun. The Sun is tilted at an angle of around 6 degrees, while Jupiter is only tilted 3 degrees. Jupiter stands almost perfectly upright, which combined with the great speed at which Jupiter is rotating, its entire day is less than 10 hours, it turns Jupiter into a giant gyroscope. Jupiter's gyroscopic stability, combined with its massive gravity, gives stability to the whole solar system. Jupiter prevents chaos factors from disrupting the orbits of the other planets. In other words, without Jupiter rotating like a stable gyroscope, the solar system could never have stayed intact for the billions of years that it has. Exoplanet solar systems are showing signs of chaos in their orbits. They could use a gyroscope like Jupiter to hold them together. Rotation is the real hero here. As for the Sun, its differential rotation has a big effect on its sunspot activity. Sunspots are spots or patches that sometimes appear on the Sun's surface, usually at mid-latitudes in both the northern and southern hemispheres of the Sun. As sunspot activity increases on the Sun, sunspots begin to move closer to the equator. Few sunspots are ever seen near the poles. With differential rotation, the gases at the equator of the Sun are moving faster than the gases at the Sun's poles. This differential motion of the gases twists the magnetic field lines in the Sun, causing them to snap. Sunspots are magnetic eruptions rising through the surface of the Sun, hurling electrified gases far into space and emitting intense ultraviolet radiation, often in the direction of the Earth. Uh-oh. Well, have no fear, Earth's differential rotation protects us. Not only does our Earth rotate differentially on its surface, but also down into its center. Studies of seismic readings of shock waves from earthquakes indicate the metallic core of the Earth is rotating slightly faster than the surface of our planet. Scientists think that the differential rotation of Earth's magnetic core within the slower rotating metallic liquid creates the magnetosphere arising from Earth's poles and extending far out into space. This magnetosphere keeps Earth safe from electrified gases from the Sun. Hurrah for rotation! Far out! Now, the 9.0 megaquake in 2011 off the coast of Japan rearranged the mass of Earth's crust and caused the rotation of Earth to speed up. The day got shorter. Not much shorter, 1.6 millionths of a second, but we are accustomed to seeing the Earth's rotation slowing down. The Earth rotating through the tidal action of the Moon's gravitational effect on the oceans drains kinetic energy from the Earth's rotation, causing the planet to slow down. Each day is becoming longer, about 0.02 of a second longer. Well, I need to adjust my watch. Leap years, we all know, are when we add a day to the calendar every 4 years, on February 29th, to straighten up Earth's yearly rotation around the Sun, taking 365 1/4 days. But leap seconds are added to the clocks every so often to synchronize our clocks with the slowing rotation of the Earth and allow the Earth to catch up with our clocks, as if the Earth is concerned about our timepieces. 27 leap seconds have been added since 1972. The last leap second was added on December 31, 2016, and made the clocks read 6:59:60 p.m. Yeah, I didn't notice either. But the Sun's rotation has unexpectedly been speeding up recently. Usually it takes 86,400 seconds for the Earth to rotate, as measured by an array of atomic clocks in different locations on Earth and coordinated by a special service in Paris. Yes, they pay people for that. July 19, 2020 was the shortest day ever recorded, a whopping 1.46 milliseconds less than the usual 86,400. Gadzooks! If this keeps up for another 5 years, they may have to add a negative leap second to synchronize our clocks to Earth's increasing rotation. Computers and satellites won't like to see their clocks read January 1st at 0 o'clock, and they say time can't go backward. At least the Earth hasn't started rotating backward or stopped rotating altogether. That would be catastrophic. Everything would crash forward at whatever differential speed it was rotating on Earth. Yet that appears to be what happened to the planet closest to Earth, Venus. Venus rotates very slowly backward, in retrograde, and that is very unusual. How so, you ask? Well, there are several theories to why Venus rotates in retrograde motion, while all the other planets rotate in prograde or forward motion. Liquids inside a rotating sphere, like a planet, have a lot of inertia. That's why when you take an egg from the fridge, for example, and try to spin it, it won't spin. The liquid inside is just sitting there. Its inertia is resisting your attempt to spin it. However, if finally, after many turns, you manage to get the raw egg to rotate, it's hard to get it to stop spinning. If you do pick it up and put it back down, the egg will start rotating again, because the inertia of the liquid inside it is still going forward. You only stop the shell from spinning. Something like this may have happened to Venus. Wait a minute. Venus? Backspin? Tennis? I think there's a connection here, somewhere. We know that on Venus, the planet, one day is longer than 1 year. It takes longer for Venus to slowly rotate around backward one time than it takes Venus to orbit the Sun once. But Venus is slowing down dramatically, and by 6.5 minutes in the last 25 years. If there still is liquid inside Venus and the movement continues, we might see Venus completely stop spinning backward and start rotating forward again. Come on, Venus, let's get with the crowd. This business of retrograde and prograde rotation has got quite a bit of mystery to it. It seems that everything tends to rotate in prograde motion. If you shape your right hand like a ball and stick your thumb up to indicate north, then curl your wrist towards you, that's prograde motion. Your fingers on the left side of your hand are moving towards you. Black holes, solar systems, galaxies, atoms, stars, etc. all seem to rotate prograde, depending on which angle you view them from. Experiments at the Large Hadron Collider indicate that subatomic particles spin toward the left, prograde. It's starting to look as if we may be in a left-handed universe. Then why is it so hard to find a left-handed manual can opener or measuring tape? I don't know. It's a mystery.
Have you ever thought about Earth itself as an intelligent, well, not creature, but maybe an entity? Like it has a mind and some survival instincts of its own. When said like this, it sounds like you're about to watch a fantasy movie where the planet we walk and live our daily lives on will suddenly wake up, realize it doesn't like us that much after all, and just go crazy. Hope not. But we're not actually talking about such scenarios, more of the idea that the collective activity of life, like microbes and plants, can change a planet and give it a life of its own. It's like the planet has a green mind. The metaphor of Earth as a living planet makes sense. Creatures across the globe crawl, swim, walk, and fly through the uppermost layers of our land, ocean, and sky. Plants cover much of our world. Plus, there are viruses and bacteria in the water, soil, and even atmosphere. Now imagine all the living things on Earth, like plants, animals, and microbes, as a giant team working together. They have different jobs, but they all do their thing to make the planet a better place to live. For example, plants make oxygen that we breathe, and animals help pollinate flowers. Together, they form the biosphere, which is like the Earth's team of life. That's where the idea of planetary intelligence comes in. Just like individuals and groups can be intelligent, so can an entire planet. Researchers believe we should measure the planet's intelligence by its ability to keep itself going forever. And just like how humans need to work together to survive, a planet's collective intelligence is measured by the capacity of all the life on it to work together towards this same goal. It's like the planet is a complex system that knows how to take care of itself. Like forests. They can share nutrients through their secret underground networks of fungi. This helps all the trees stay healthy. We can obviously learn a lot from forests. If we jump into the fantasy universe while looking for intelligent, conscious planets, we definitely choose Mogo from Green Lantern. It's a specific planetary entity that can do things like changing its weather and altering gravity, plant growth, or some other surface conditions. Or how about the stunning Pandora from Avatar? Do you remember the fascinating scenes of flora and fauna there? With organs that might remind you of tentacles. They enable creatures to interlink with each other on a neural level. It's like the entire planet is like one giant brain, with many smaller trees, creatures, and its other pieces as its cells. We're far from that, but it's still nice to imagine. At the moment, our civilization is in the stage scientists named an immature technosphere. That means we're still too focused on using technology that doesn't always do good for our planet. We don't have a planetary intelligence or a collective understanding of what needs to be done to do better for our planet. Instead, we're all just doing our own thing. I mean, we're not at the worst stage. Researchers have come up with 4 stages of Earth's past and future to explain how planetary intelligence could impact the long-term future of humanity. The first stage is what we call the immature biosphere. It's when life first started on Earth, billions of years ago. Only microbes were there on the bare land without any vegetation. There wasn't any global feedback, which means these microbes couldn't yet affect Earth, its atmosphere, or other systems in any way. The second stage is the mature biosphere, which was 2.5 billion to 540 million years ago, when stable continents formed and the biosphere started to have a strong influence on the Earth. The third stage, known as immature technosphere, is where we are now, with interlinked systems of communication, technology, transportation, electricity, and computers that draw resources from Earth's systems and affect the biosphere. The fourth stage, also known as the mature technosphere, is where Earth should aim to be in the future. It means technology will benefit the entire planet. We'll use sustainable forms of energy, like solar power. Planetary intelligence is the sign of a mature planet, and researchers are trying to figure out how we can move towards it. So, things we do on an individual level do matter. The collective activity of life, like microbes or plants, can change a planet and make it more than just a lifeless rock floating in space. Through the biosphere, our home planet kind of figured out how to host life by itself billions of years ago, and it's still going. Now we need to figure out how to have a similar kind of self-maintaining system, but this time with the technosphere. It's hard to imagine planets could generally become sentient, like Pandora or some other imaginary conscious world out there. There are a few reasons for that. First, planets form based on how different materials like rocks, gases, and liquids gather around a new star. It's like you have a big family gathering, where everyone brings different ingredients to make a delicious dish. And just like how these ingredients won't suddenly turn into a living being, the materials that make up a planet won't just turn into self-aware creatures. On Earth, after billions of years of complex chemical reactions, some molecules started to replicate themselves and carry information. That's how life on our planet began. And Earth is the only such example we have. Here's the second reason. Imagine you have a big garden where you plant a lot of mushrooms or bacteria, hoping they'll become really smart and help you take care of the garden. But mushrooms and bacteria don't have brains like we do. It's not like they need it anyway. Having a big brain is really expensive for animals too. It takes a lot of energy to keep it running. So, animals only become as smart as they need to be to survive and thrive in their environment. Dogs and cats are pretty smart because they need to be able to avoid danger and find food. They don't need human kind of intelligence for things like building houses, creating art, or inventing new technologies. So, it would be hard to bring all living beings and plants to the same level of intelligence. The third reason why it would be difficult for a planet to become sentient is the main rule of the animal kingdom. Life is all about survival of the fittest. Every creature is competing for resources like water, food, and space. But not only do different species compete against each other, but individuals within the same species also fight. Just think of how fiddler crabs fight for territory on the beach, or how wolf packs fight over prey. Or me, when I see an empty spot on a crowded beach. This kind of competition is not a good base for global cooperation. There are a couple of exceptions to this rule. For example, ants. They may not be the brightest creatures on the planet, but when they come together in colonies, they can achieve amazing things, like gathering food that's way bigger than them, building nests, raising young, and even farming. In fact, they act like a superorganism called a hive mind, where every ant works together towards a common goal. Insects like bees and ants are very altruistic and work together to ensure their queen reproduces. If one large ant colony took over our whole planet, it could act as a single mind and work towards the colony's and planet's interests until they run out of resources. But in reality, it's hard to imagine any organism, even a superorganism, could reach such a level of self-awareness and consciousness. Number 5. How could we keep in contact? When it comes to communication, ants use pheromones and humans use nerves. Both of these methods work well for small organisms, but when it comes to a giant planet-sized entity, it would be hard to make such communication fast and efficient. So, communication within a planet-sized entity would be much slower than what we have in our homes, like our computers or smartphones. Oh well, we'll just continue dreaming about Pandora.
Check this out. What were 60,000 jellyfish doing in space? The backstroke? When and why was Niagara Falls dry? Where can you see a green sunset and a flowering desert? Let's dig into some of the Earth's mysteries. The Earth had a second moon. A space rock the size of a car had come up too close and had been tangled into our planet's gravitational pull for at least a year. In March 2020, it left Earth for the Sun's orbit. This was only the second confirmed mini-moon after the one spotted in 2006. In 1991, NASA sent to space around 2,500 jellyfish polyps in bags with artificial seawater. By the end of the mission, they had multiplied to 60,000 jellies. Scientists wanted to see if jellies born in space would be able to adapt to Earth's gravity after coming back. Sadly, they didn't do so well. Humans and jellyfish have similar gravity-sensing structures, so humans born during long future space missions could have some massive vertigo back on Earth, too. In 1859, the biggest solar storm ever was recorded. It was so powerful, northern lights were spotted in Cuba and Honolulu, and southern lights were seen as far up as Santiago, Chile. In latitudes like that of New York, people were able to read newspapers in the dark under those northern lights alone. If something similar happened today, it would have cost the world about $1.2 trillion. Speaking of rare bright lights, have you ever spotted a green flash? It happens shortly after sunset or before sunrise when the sun is almost entirely below the horizon and the Earth's atmosphere bends and scatters lights from it. People mostly spot it over the ocean. It can also be yellow, blue, or purple. I've actually seen one myself. Lucky me. When Kawajian volcano in Indonesia erupts, it looks like it's spitting out bright blue and purple lava. In fact, the lava itself is normal. It's the sulfuric gas coming out of the magma chamber and burning that makes it look so surreal. For the same reason, the water in the crater lake seems bright blue and the shores electric yellow. Niagara Falls was once dry. In 1969, engineers turned off 2 of the 3 falls making up the landmark. They did it to remove the rocks that had piled up at the base of the falls. Over the first weekend of the renovation works alone, about 100,000 tourists visited the spot. In Racetrack Playa, California, rocks about as heavy as a horse are moving around on their own and leaving trails behind. There were different theories to explain this, from magnetic fields to aliens. Finally, a NASA scientist found out that in winter, rainwater in the playa freezes over. Rocks get encased in ice. When it starts to melt, even a light breeze is enough to move the boulders around. Once a year, for just a few moments, a waterfall in Yosemite National Park turns into a firefall. In winter and early spring, 2 streams flow down the granite El Capitan. In perfect conditions in February, when the sun is hiding behind the horizon, it gets in the right position to reflect off the wall and color the water fiery orange. The Danakil Depression in Ethiopia is a one-of-a-kind landscape with crackling pools of lava and neon hot springs and geysers. It's one of the hottest and lowest places on Earth that hardly receives any rainfall. Scientists studied this area to find out how life might evolve on other planets. Many of them call it the cradle of humanity. Some places on Earth have less gravity than others. Canada's Hudson Bay, for example, used to be covered by a super thick and heavy glacier during the last ice age. The ice had pushed tons of rock mass outward when it started to melt. The smaller the mass of an object, the less gravity it has. It'll take another 5,000 years for the Earth to return to its original shape in this spot. There are underwater lakes and rivers in the ocean. The water in them is denser and more saline than the rest of the ocean. They have shorelines, surfaces, and even waves. And smaller rivers also flow into larger ones. They can be found across the world, from the coasts of Greenland to the Bay of Bengal. One of the most unique natural optical illusions on Earth is an underwater waterfall off the coast of Mauritius. No worries, the island isn't going down the drain. Sand is moving through the underwater currents into the darker, deeper ocean and creates the illusion. The shelf here is 10 times deeper than the rest of the surrounding waters. There used to be a never-ending wave in Brazil. The Pororoca, which translates as Big Roar in the Amazon basin, went on for hours and was so powerful it could take down trees. Surfers from across the world came here in early spring to ride more than a half an hour in a row. The record was 6 miles non-stop on a single attempt. One of the driest places on Earth, Chile's Atacama Desert, turns into a garden every 5 to 7 years. With enough rainfall between September and November, superbloom spreads overnight. The seeds of over 200 types of flowers sleep in the ground for months or years, waiting for that water to help them sprout. Mineral gypsum sometimes crystallizes in a rose shape. It happens in dry, sandy areas that occasionally get flooded. The petals of desert roses are made of crystals that get mixed with grains of sand. Lake Maracaibo in Venezuela is often called the lightning capital of the world. Thunderstorms happen here 300 days of the year, with a peak in September. Sometimes there are up to 200 flashes in a minute. It happens because cool air coming from the surrounding Andes meets with warm air from the Caribbean Sea and generates electricity. In 2010, spiders cocooned the trees and bushes in Pakistan. They did so to save themselves from a flood when 10 years' worth of rain poured down in a single week. Some of the webs even stretched over several trees. One of the rarest types of clouds are lenticular clouds that look like giant mountain hats. They're formed when moist air is traveling over a mountain or a mountain range and gets into an area of turbulence. They are so rare in flatland, people sometimes take them for unidentified flying objects. You can spot flowers in the Arctic Ocean in the midst of winter. These frost flowers are made of ice, in which microbes somehow manage to survive. Studying them could help scientists better understand how life formed on Earth. Lake Abraham in Canada looks like it's home to tens of thousands of jellyfish living under ice. In reality, they are frozen pockets of methane gas produced by bacteria that live in the lake. There is a cave in New Zealand that's lit by glowworms. Waitomo caves were discovered in late 19th century and have been popular with tourists ever since. There are thousands of bioluminescent larvae of various worm species in the caves. All of them are harmless. One of the oldest and largest organisms on Earth is a clonal grove nicknamed Pando in Utah. It looks like 47,000 trees, but in fact, it's one huge tree. It has 3 sets of chromosomes instead of 2, and can keep making unlimited new shoots from its own roots. Scientists believe it's at least 80,000 years old. Volcanoes can produce lightnings. They're formed in columns of volcanic ash through friction and static electricity to connect the positively and negatively charged particles. To understand how it works, you can rub a balloon across your hair or your feet across a carpet and then touch a metal doorknob. Yeah, go ahead. I'll wait. Nah. About once a year, you can spot a rare firenado in the U.S. Fire tornadoes start when a strong wind picks up heat from a fire. They're made of flame or ash. They're different from regular tornadoes because they don't start from cyclones. Firenadoes are about as tall as the Leaning Tower of Pisa. Unlike firenadoes, fire rainbows don't cause any damage at all. They aren't about fire or water. Fire rainbows only happen when the sun is very high in the sky and its light is passing through ice clouds. A white rainbow is a rare illusion created by fog and water. Like a usual rainbow, it's formed when light is shining through droplets of water. It loses color because fog droplets are hundreds of times smaller than those of rain. A white rainbow is sometimes mistaken for moonbow. That one happens at nighttime and is illuminated by the moon. That's why it's not so bright. Kinda like me.